Services can be either simple or complex, but either way, they share certain characteristics. Simple services, for example, are regular data access services or services that are there for the purpose of just regular data retrieval. For example, just retrieving a product record for a given idea. In this case, the service is nothing more than a managed wrapper, an orchestration wrapper for the data access layer. There's really no business functionality in between there that's necessary. It's just a matter of calling the service and having the service go to the database and retrieve information. Now, even in a service as simple as this, we should still have proper architectural layering, meaning the actual task of retrieving information from the database itself should be delegated to a data access layer. But in this particular example, the service would simply become a wrapper for that data access call and provide to that call characteristics that I'll soon talk about. Now, a more complex service example would be something like a e-commerce type of service. This is a service whose job is to be called from the outside world for the purpose of processing an order in an e-commerce scenario. Now, the business task of processing an e-commerce order involves several steps, and each one of those steps is radically different from the other and involves different types of technology to be used. For example, you may need to take that packaged information that the client sends, which includes shopping cart information, customer information, product pricing information, credit card billing information, and you may need to do certain things like update the data records of the product inventory to denote that that product has been purchased by a certain customer, and of course update records for the customer history and the customer purchase history. You may need to process the customer credit card information through some kind of billing gateway or payment processing gateway. You would need to build an invoice with line items and email it to the customer. You may need to perform some logging. All of these are separate steps, and they're all initiated by one call to an e-commerce service that says process this order. This is a more complex service. This is a service that is not only calling upon the data access layer to update database information, but also probably a couple of business engines to do things like building an invoice or maybe a notification engine in order to perform the notification of an email or the sending out of an email to the customer. Maybe even calling to another service that does all of the payment gateway functionality. Maybe a third-party service like CyberSource, Authorize.net, Intuit, or PayPal, or any of those. So both of these examples, a simple data retrieval or a complex e-commerce processing, are still examples of a service, and they all share certain common functionality or common characteristics. These characteristics are that either one should be simple to call from a client, either one should be the single point of entry for the client. What this means is that the client should not call into the one piece of the order processing service that simply sends out an email notification or processes a credit card. The client needs to just package up a bunch of data and send it to a service and tell the service to do its job, and then call me back when that job is done, or call me back if that job fails for some reason. Now, this leads me to another one of the characteristics that all services should have, and that is it should be properly fault handled, which means that the service needs to perform what it needs to perform and account for any potential exceptions or faults, as they're called in the service-oriented world, that may come up. It should also have a way to get those faults back to the client so the client knows how to properly act upon them. A service, whether simple or complex, should also leave the system in a consistent state. This alludes to the topic of transactions, which means in a simple service, you may be talking about just data retrieval or maybe a one-time data update or one table update. But in a complex service, like my e-commerce example, we may be talking about several steps. And as far as database work is concerned, we may be talking about updating several parts of the database. Now, all of this needs to be done in the context of a single transaction, which means if any one of these things fail, if the credit card processing fails, or if the creation of a single invoice line item fails, you do not want partial information to be committed. So you want to back out the entire thing and then send information back to a customer that's going to tell them, I can't process your order at this time. Let's try again a little later. Another characteristic that all services, simple or complex, should share is that they should be secure. Now, this doesn't mean that every single service has to have security applied to it, because you may very well have a reason for writing public services that just give information to the outside world and no security is necessary. However, for the most part, I think it should be said that most services are going to have some amount of security on them. A service should also handle threading properly. So it should allow more than one concurrent user in to perform its services or its functions, or it should allow only one at a time. That's up to the task at hand, but it should all be encapsulated and managed by the service itself. So as you see, all of these characteristics are that of a full-blown application, but they're narrowed down to one service. So there's one service knows how to do and handle all of these characteristics, all of these things into kind of a black box, a unit of work access point. This is the access point that the client will have access to in order to perform that particular task. And the service knows how to handle everything regarding that unit of work in a rock solid fashion.